All right, we're still working on section 1.5. We're doing part 3. Evaluate each expression when x equals 2, y equals -3, and z equals 4. So just on the side here, x equals 2, y is -3, z is -4. All right, so the first one is x minus y plus z. We just plug those values in. In place of x, we're going to put a 2. In place of y, we're going to put a -3. And in place of z, we're going to plug in a -4. All right, so we have 2 plus 3, right? Because minus a -3 is plus 3, plus -4, which is 5 plus -4, or 1. Okay, because you're writing a positive and a negative, more positives than negatives, so you do 5 minus 4 to get 1. All right, here's number 2. Again, we're going to plug in the values for x and z for this problem. But before doing that, I suggest you rewrite x cubed as x times x times x. You don't have to do that. I like to do it that way. Usually fewer mistakes occur. So we're going to now plug in the values of x and z. So we start off with z, so we have to plug in -4 minus 2 times 2 times 2. Now somebody else may have simply plugged it in right away as -4 minus 2 cubed. That's also fine. But be careful if you're plugging in a negative number for the variable and you're raising it to a power. So for instance, if this was -2, you would have had to put a -2 in parentheses. All right, so I like doing it this other way, then I don't have to worry about that. So we've got -4 minus, right, in the order of operations, you need to do multiplication before subtracting. So that's 8. And if you did it this way, you would do the exponents first. So 2 cubed is 8, just like 2 times 2 times 2 is 8. So we've got -4 plus -8, and we're adding 2 negatives, so the answer is negative. Add 4 and 8 to get 12. So our answer is -12. That's number 2. Going on to number 3. We have x minus y all over z plus 2. So the first step here is to plug in the values again. So let's put in 2 for x, -3 for y, -4 for z, so we've made all of our substitutions. And then remember, you have to simplify the numerator and denominator separately. No canceling until you've completely simplified the numerator and denominator. All right, in the numerator here we have 2 minus -3. Remember the 2 pencil strokes? You could think of that, change it to plus and plus. That's going to be a 5. And -4 plus 2, you're adding a negative and a positive. So the negatives outweigh the positive, and we do 4 minus 2 to get -2. Now, you do not want to leave an answer with a negative sign in the denominator. If there are 2 negative signs, then they would cancel. But in this case, it's a positive divided by a negative. You want to write your answer as -5/2. If you want, you could put the negative in front of the 5. And it is the same thing. It just doesn't look as simplified when you have a negative in the denominator. Or you could write this as a mixed number. Just make sure the fractions are reduced. And in both of these, the fraction is reduced because there's no number that goes into 5 and 2 or 1 and 2 except 1. And here's number 4. Again, we're going to begin by plugging in the values for x and z. Now, since x is positive, you could just write 2 squared, or you could write that as x times x and then get 2 times 2. I'm going to do it the simple way this time, just writing 2 squared minus a -4 is what you're going to plug in for z. And then on the bottom, you're going to plug in a -4 for z, minus 3, and then we have to plug in the value of x, which is 2. So this could just be times 2, because 3x means times 2. You could put that in parentheses if you like. It doesn't matter. And by the way, the -4 could also go in parentheses at the bottom here. Usually when it's the first term, I don't put it in parentheses. All right, now we need to do the order of operations in the numerator and denominator. Simplify each first. Okay, so in the numerator, what do we have going on here? I'm going to write it over to the side. We have 2 squared minus -4 will be a plus 4, correct? 2 squared is 4, so 4 plus 4 is 8. So in the numerator, we're going to have 8. All right, now what's going on in the denominator? So here's the numerator. In the denominator, we've got -4 minus, when you multiply, 6. So that's -4 plus -6, which is -10. So my denominator is -10. Again, you have a positive divided by a negative, so you want to just put the minus sign out in front of the fraction bar and reduce 8/10. 2 goes into both of those numbers, so the answer is 4/5. So -4/5. You could put the negative up in the numerator in front of the 4. I like to see it in front of the fraction. It just shows you've got a negative fraction. All right, we're going to part 4 in 1.5. So let x equals 56 degrees. That's an angle. If x and y are complementary angles, find y. Now the hint is complementary angles add up to 90 degrees. So we have to think about what the other angle is if those add up to 90 degrees. So we just subtract from 90. 90 minus 56. And that's going to be 34, so the answer is 34 degrees. That's the complementary angle. All right, let's do the next one. X and y are supplementary angles. Well, supplementary angles add up to 180. So this time we just subtract from 180 instead. It'd be 124 degrees. Oops. Remember to put the degree symbol. Something you might notice is the supplementary angle is 90 degrees more. So 34 plus 90 is 124, because from 90 to 180 is going to be 90 more degrees as well. So they should be 90 degrees apart from each other. Okay, we're doing some concept problems for part 5. This is still section 1.5, part 5. If p is a positive number and n is a negative number, state whether each statement is true or false. If it's true, provide an example showing it's true, and if it's false, provide an example showing it's false. I'm going to leave you to do an example, but let's just sort of analyze this. A positive number plus a negative number. Is that always positive? No, because if the negative number is a larger absolute value, it's not going to work. So this should be false, and you should be able to come up with a negative number and a positive number that when you add it up, you'll end up with a negative number. Okay, a positive number minus a negative number. So try some positive number and try some negative number and see what happens when you take the positive number minus a negative number. It will be positive, actually, because if you start off with a positive number and you subtract a negative one, you're going to end up adding a positive number. So I'm going to leave you to pick a number that's positive and a number that's negative that'll show that is always true, no matter what you try. Okay, how about a negative number minus a positive number? Is that always positive? Don't think so. I think that's going to be false. Let's check this one out. Let's just do one. How about if I pick like -10 for my negative number? Got it? Then I'm going to subtract. Let's pick a positive number, like 4. Do you see how it ends up being a negative number? So that might be an example. I'm plugging in -10 for my negative number, and I'm plugging in 4 for my positive number. So I'll let you do an example for 1 and 2. Right, and that ends all the problems from 1.5 from the review.